In this use case, I'm building a voice bot to handle vehicle insurance claims. The bot will answer calls, identify and authenticate the caller, and then manage the whole vehicle insurance claims process for windscreen and hail damage. You can see the dashboard screen for this new agent we are building. In the right-hand panel, we have the conversational design being mapped out, and in the main panel, we are creating the nodes. These nodes are building blocks to direct the conversational flow. The nodes are used to collect data from the caller, confirm the accuracy of what has been captured, control the logic of the interaction, communicate with the client's internal systems, and provide information back to the caller. Under the hood, our language model is trained to understand the meaning behind the caller's utterances, even when said in a variety of different ways. The conversation path is created real-time throughout the call, with the system continually ensuring the most efficient path to solve what it is that the caller needs to get done. The conversation is designed without coding, and the flow is created using nodes via drag and drop. You can see how user-friendly the dashboard is and how it facilitates the straightforward building of even complex conversational interactions. In this example, the agent is being set up to answer the call and ask the caller for their South African identity number. This is then checked firstly to ensure it is a valid 13-digit identity number, and secondly, against the call center's database to ensure the caller is a customer. We're able to set accuracy parameters to validate information dependent on the nature of the information required from the caller. So, for example, in entities such as ID numbers and bank account numbers, where we need a high degree of precision, the parameters would be set high. And for more general utterances or names where there could be different spelling, we would set a lower accuracy threshold. We are building in two fallbacks in this example. If the agent doesn't understand the caller at the first attempt, we will ask them the question in a different way and ask them to repeat the ID number slowly. And if that still doesn't work, then deflect to DTMF tones so the caller can type their ID number into the phone. Once the caller is identified, the agent will retrieve their mobile number from the database and send a one-time PIN text to the caller for them to read back to the agent. Assuming the caller reads the OTP correctly, the identification and verification process is then complete. If at any point in the journey the agent encounters a roadblock, or if the caller's details do not match records, the agent will hand across to a human operator. The caller can also ask to speak to a human at any point. Once the call has been verified, the next step in the journey is to establish what the claim is for. In this example, the options are glass damage, hail damage, theft, or an accident. For glass and hail damage, the claims are fully automated with the agent asking for the vehicle make and model, which it matches to records, the date and time of the incident, a short description of the incident, and the details of any damage done to the vehicle. The agent will confirm that the claim is approved and send an SMS notification or email to the caller with the following details: the claim reference number, confirmation that an instruction with all relevant details has been sent to the Fitment Center and that the center will be in touch with the caller shortly, the Fitment Center's details, and confirmation of the excess amount. This entire journey took less than 2 hours to build and with no coding required. It is automating an insurance process that for large call centers could be thousands of calls per day, each taking an average of around 5 minutes of a human operator's time. We're achieving a digital agent success rate of 98% in use cases around authentication and validation, well ahead of what one could expect even the best human operator to perform it.